Let us take a scenario where you want to generate a list of most recent posts from friends for the news feed in a social networking application. In a tabular database, you might maintain the friends and posts information in two separate tables and connect them with foreign keys. Firstly, you would get a list of friends for the logged in user, then get posts for each friend within the for loop. Lastly, accumulate all posts in a list sorted by date and return the top n records. However, this approach is not efficient. It gets slower as the number of friends and their posts increase. In this approach, time complexity is linear. Here is a tabular representation of the data. Here, let's say that if Alice logged into the social networking application and if we are generating newsfeed for Alice, we will pull two friends first, and then for each friend we will be pulling posts. Instead of storing all data in tables, we could use a graph database and store relations like friends, followers, and post reactions with their IDs. Later, IDs from the graph database can be used to get details. With that said, we still save user and post information in a transactional database like DynamoDB, so we can take advantage of both databases. With this approach, the app can sustain constant time regardless of the number of friends and posts. The following graph representation of relations is more intuitive than the tabular representation of data, and here we can easily see that the user 1 has posted posts 1 to 4, and the user 2 is friends with user 1 and 3. The user 2 also reacted and commented on the post 1. When you go to AWS Neptune console, and in the sidebar, if you click on the notebooks, then you will see the database notebook instance, which is created with your graph database. If you select the Neptune instance and click on actions, then you can open up a Jupyter Lab for running queries, and you can also open up the Graph Explorer, which visualizes your graph database. Once you are in the Jupyter Lab, then you can run %status to see if your database is up and running. If we execute that, then we see that its status is healthy and when it was started, and the database engine version, plus the versions of supported graph languages such as Gremlin, SparkQL, and OpenCypher. You would also see some configurations about your graph database, such as if the IAM authentication is enabled or not. If it's serverless, then how many Neptune capacity units you have. You can also see the cluster timeout, which you can customize with parameter groups. The Neptune supports 3 graph languages, and they all have its weaknesses and strengths. For example, when you are using Gremlin, you can set ID for vertices and edges. But then if you use OpenCypher instead to create a vertex, then you cannot set an ID. Similarly, here I wrote the query for adding a vertex smoothly, even if the same vertex exists in the database. I run this command, and this first it finds the vertex, and if it exists, then it does nothing. Otherwise, if it doesn't exist, it adds the vertex. The same thing that you can do with OpenCypher, and in my case, this command is much more readable. So it just merge, and then it do the upsert operation, and that doesn't break already existing vertex. And here is a command. If we execute that, it would add users with user 1, 2, and 3. So we are not storing any property, any extra information, because once we got the ID from the graph database, we can pull the details from other transaction database such as DynamoDB. Here, as I am running multiple commands, here you have to add the iterate function, which makes sure all these commands are executed. Once we executed, then we can see how long it took. And then let's double check with Gremlin if those vertices are created. And then it took a while, but you will see those 3 records have been created. We have vertices for users, and now let's set some relations. In this case, user 1 is friend with user 2, and then they became friends at this time. And similarly, user 2 is also friend with friend 1. And user 2 is also friend with user 3 and vice versa. Okay, we have successfully added the edges. So now we can visualize this. So for that, if you open up the Graph Explorer, then you should see the newly added vertices. So here, our first vertex in our Graph Explorer, and as you see here, this label 2, which indicates how many edges it has. If you double click on the vertex, then it will automatically expand the vertex, and then you will see all connected edges and vertices. In Graph Explorer, you can always customize these vertices. For example, here for post, I uploaded this icon, and for user, I uploaded this icon. Similarly, you can change its background colors and other styling. If you click on here, then you can also customize the styling for edges. So I customized all of this. Plus, if you click on this edge, for example, this friend with edge has a property timestamp, and for that you can click on these details, and then you can see that information with this graph visualizer. Let's switch back to the Jupyter Notebook and let's run some commands. In this case, we are counting the number of friends for user 2. So there are 2 ways to do. First thing is you can directly get the vertex by its ID, user 2, and then we will just count the outgoing friend with edges. But in most cases, developers find a vertex with this has label and has function. And then this is executing the same command. If we run this, as you see here, user 2 has 2 friends. And now let's add some more vertices and edges to our graph databases. In this case, user 1 has posted post 1. And notice here that we are adding the vertex and edge at the same time. And then here we added a property for the edge. So add stands for add edge, that adds the connection. And user 1 has posted post 1 to 4. Similarly, user 3 has posted post 5 to 6. Whereas user 2 didn't post anything, but who comments and reacts friends' posts. For example, user 2 commented on post 1. Commented edge as a property which we can use later on to get details on this comment. User 2 also reacted on post 1 while writing a comment, and then reaction type is like, and then user 2 has also reacted to post 2. In this case, that user sent care emoji. Let's run this. So we have executed all these commands and added the vertices and edges. After executing these commands, we can see its visual representation in the Graph Explorer. So we can remove the current vertices on the dashboard to get new data. Click on the top bar and you will see all these new vertices. Let's click on the user 2. If we click on this, now you will see that user 2 is friend with user 1 and 2, and also user 2 has commented and reacted on post 1. Similarly, we can expand it. For example, user 1 has posted post 4 and 3, and then expand user 3, then we can see some more edges and vertices. And then as you see here, I already customized the styling for these edges. Finally, we are ready to write a query that answers the initial proposal. Generate a list of most recent posts from friends for the newsfeed. Let's find the user who logged in the system and then find its friends. User 2, and then we are traversing through the friend with edge. Then our first query will return user 2's friends. For example, user 1 and user 3. Let's run the command, and as you see here, we traversed through the graph and it returned user 1 and 3. From there, we can find the posts through the posted edge. So for each friend, we are traversing even further to get all those posts. For that, we can traverse from user 2's friends to its outgoing and just post. And here, as you see here, user 1 posted post 1 to 4, and user 3 posted post 5 to 6, and user 3 and 1 are friends of user 2. And if we notice, this posted edge has timestamp that we have to sort it by date because we want to get the most recent posts. For that, we can call the order function and sort it by timestamp in the send. And you can, if you run this command in Gremlin, you will get the result. And when you use this element map function, it also gives you a graph. So here, user 1, and if we scroll here, you would also see the other user. With Jupyter Notebook and Gremlin, you can also get graph representation. We will get the most recent N records. In this case, it's 20. And then to get the post ID, we have to traverse even further, grab the vertices from the edges. So here, post vertex has its ID. So lastly, we are grabbing these vertices. We execute this, then these are the post IDs that user 2 would see on the newsfeed. To summarize, graph databases are more intuitive than traditional tabular databases because we naturally visualize relationships as graphs. This makes graph databases more realistic and effective for solving real-life challenges. Graphs are not just an advanced concept in computer science or on platforms like LeetCode. They can be very practical and useful in real-life projects. If you have any questions on this lesson, feel free to leave a comment. Thank you for watching and you have a good one.